So here we have an equation that looks a little bit like the circles equations we've been dealing with. It has an x squared term and it has a y squared term. So it's close to our x squared plus y squared equals r squared, but we have this plus 6x. So I need to do something called completing the square. You might be familiar with that term from Algebra 1, from one way to do some factoring in order to determine the zeros of a parabola, and in order to figure out how to graph a parabola. So you may have seen something like this before. So the first thing that I need to do is find the magic number. So the magic number comes into play when I have either an x to the first term or a y to the first term. So I'm gonna figure out some number to add right here after the x squared term and the x to the first term. So that number comes from half of the coefficient with x to the first. So 6 divided by 2, which I know is 3. And now I'm going to square that number. 3 squared is 9. So I'm gonna add in a 9 right here after the plus 6x. The reason I'm doing that is because it's going to give me a perfect square trinomial that I can factor. Okay, so this is what that will look like. So we'll have x squared plus 6x plus 9. And then let me do my y squared here, plus y squared equals 40. But anything I do to the left side of my equation, I have to also do to the right side. So since I added this plus 9 here, I also need to add 9 to the right side of my equation. So again, this 9 came from taking the coefficient in front of the x to the first, dividing that by 2 to get 3. And then I need to square this value. 3 squared is 9. So the reason I did that is because if I focus on just what's in blue, this trinomial, x squared plus 6x plus 9, if I factor that, so factoring, I'm looking for two numbers that multiply to give me 9 and that add up to 6. Since these are positive, both of these will be positive. And then two numbers that would work there are 3 and 3. Okay, so x plus 3 times x plus 3 will give me x squared plus 6x plus 9. I can rewrite this though. Since I'm multiplying the same thing times itself, I can rewrite that as x plus 3 squared. So that was our goal all along, was to create this trinomial that I can factor into a binomial squared. So this is back to looking like our equation for a circle where the center is not at the origin. Okay, so x plus 3 squared, and then I have plus y squared, and that is equal to 49. So now let's determine what is the center of this circle. So according to the x value, I have to change the sign here. So the center is -3, and then y squared is just on its own. There's nothing inside the parentheses with y. In my original equation, there wasn't a y to the first term, so that's why I didn't have to do anything with my y's. So that means the y value is 0 of the center. And then the radius comes from the right side of my equation here, 49. Remember, the radius is the square root of what's on the right side of the equation. So it's the square root of 49, which is equal to 7. So my center is -3, 0. My radius is 7.